Hello everyone, myself Chaitanya Parekh and today I am going to present my CA activity on data transmission. Firstly, we will see what is data and signal. Basically, data is an information that is to be transmitted from one device to another. The data can be of two forms, analog data and digital data. The example of analog data is an voice recording and the example for digital data is an file on a disk. Now we will see signals. A signal is an electric current or electromagnetic field used to convey data from one place to another. Digital signals. Digital signals are discrete in nature and represent sequence of voltage pulse. Analog signals. Analog signals are continuous waveforms in nature and represented by continuous electronic waves. Now we will see what is data transmission. Data transmission is the transfer of data from one digital device to another. Basically, the data transmission is of three types. There are simplex transmission, half duplex transmission, and full duplex transmission. Basically, simplex transmission is the transmission in which the data is transmitted in only in one direction. In half duplex transmission, the data is transmitted in both the direction but one direction at a time. And in full duplex transmission, the data is transmitted in both the direction at the same time. There are two methods of data transmission, analog transmission and digital transmission. Now here in this figure, it shows the block diagram of data transmission in which it shows the input data which is received from the sender device to the transmitter. The data is transmitted towards the transmission medium while the data is converted into the signals. And then through transmission medium, the signal is received to the receiver where the receiver converts the signals into output data and sends it to the receiver device. Now we will see transmission media. Basically, transmission media is the medium over which the data is being transmitted. Transmission media is of two types, guided media and unguided media. The example for guided media are wires and cables, and for example for unguided media are the Bluetooth and Wi-Fi. Now we will see digital transmission. Basically, digital transmission is for a computer to use data. The data has to be in digital form. So to convert the data in digital form, digital transmission is used, in which we see two types: digital to digital conversion and analog to digital conversion. Now first we will see digital to digital conversion. In digital to digital conversion, digital data is converted into digital signal and it can be done in two ways, line coding and block coding, from which line coding is always necessary and block coding is optional. Now we will see line coding. Basically, line coding is the process of converting digital data into signals, and digital data is being found in binary format which is represented in the series of 1 and zeros. Digital signal is denoted by discrete signal which represents digital data. There are three types of line coding: unipolar encoding, polar encoding, and bipolar encoding, from which unipolar encoding is the scheme in which single voltage level is represented. In polar encoding is the scheme in which multiple voltage level is represented, and bipolar encoding is the scheme in which voltage levels are represented, from which positive, negative, and zero. Zero voltage represent binary, and bit 1 is represented by alternating positive and negative voltage. Now we will see block coding. Basically, block coding is used to ensure the accuracy of received data frame redundant bits from which are used. Now we will see analog to digital conversion. Basically, analog microphones create analog voices, cameras create analog videos, which are treated to analog data. To transmit analog data from digital over digital signals, we need to convert the analog to digital. Basically, analog to digital conversion is done using pulse code modulation, in which pulse code modulation involves three steps: sampling, quantization, and encoding. Basically, sampling is the uh, taking of discrete values by time to time on the device. In this figure, one analog signal is shown, and when the sampling of that analog signal is done, there are many discrete signals plotted on the graph according to the time. Then the quantization. Basically, quantization is of converting that sampling rate to the digital signals. And then the encoding. Basically, encoding is the scheme in which the data is converted to the binary form. Now we will see analog transmission. Basically, in analog transmission, there are two types: digital to analog conversion and analog to digital conversion. To send data digital over an analog media, it needs to be converted into analog signal. So therefore, we will see for digital to analog signal. In digital to analog signal, when the data is in digital form, it is to be converted to analog signal. So it can be sent to an analog device. So the digital data can be converted in analog by using three types: amplitude shift keying, frequency shift keying, and phase shift keying. In an amplitude shift keying, the conversion of amplitude of analog carrier signal is modified to reflect binary data. In frequency shift keying, conversion technique of frequency of the analog carrier signal is modified to reflect binary, and in phase shift, same the phase of the original carrier signal is altered to reflect the binary data. Now analog to binary analog conversion. Basically in analog to analog conversion also there are three types: amplitude modulation, frequency modulation, and phase modulation. In three types, in amplitude modulation the amplitude is modified to reflect analog data. In frequency is modified to reflect frequency data. And in phase modulation, phase of the carrier signal is modulated in order to the change in voltage of the analog data signal. Now we will see transmission mode. Basically, the transmission mode decides how data is to be transmitted between two computers. There are of two types: parallel transmission and serial transmission. Basically, parallel transmission, both the binary bits are organized in groups of fixed length. Both sender and receiver are connected in parallel when the equal numbers of data lines. Both the parallel transmission, both the high order and low order data lines, the sender sends all the bits in ones on the all lines. And now in serial transmission, basically in serial transmission there are two types: asynchronous and synchronous. Basically asynchronous serial transmission, the bits are of bits does not depends on time, so the data have specific patterns and they help receiver recognize the start and end data. But in synchronous serial transmission, timing in synchronous transmission has importance as there is no mechanism followed to recognize start and end data bits. Therefore data are sent in burst mode without maintaining gap between them. And these are the reference from which I have gathered the information for creating the PPT. Thank you very much.